Okay, so today is 9.3, and you're going to learn how to go from polar to rectangular and rectangular back to polar. What does that mean? This is what we're doing today. On a bullseye, this spot right here is kind of like 3 comma 30 degrees, correct you guys? If you put this over your original x's and y's, wouldn't it be this dot right here if you overlay those on top of each other? And wouldn't this be some x and some y? And I'll figure out what the x and y value is so that whatever that point is and that point, if you overlay them over the old version of what we learned in algebra over the new polar, they should land exactly on the same spot on a graph. And that's all we're really learning today. So here are the formulas. And on your formula sheet, we're on the back side of the formula sheet. Converting polar to rectangular, converting rectangular to polar. Right in the middle, down at the end, in the middle of the page, you should be able to find this formula and these two in the middle of your formula sheet. Everybody see where they are located? Okay, so to go from polar to rectangular, it's just these. It's y equals r sine of theta, x equals r cosine of theta. R stands for the radius, this stands for the angle. That's how you get back to x's and y's. And then in order to put it back into polar, we're going to use this formula. It'll be easier just to explain it to you as we go, to use the formulas. So here we go. We're going to learn how to go from rectangular to polar. So this is x, this is y, this is x, this is y, this is x, this is y. And what I'm going to give you is the same points that's an r and a theta. And that if you overlaid themselves on the same graph, it should be the same point, correct? And it's not, it's really easy. I don't know why I just put those in there, they're supposed to go below them. But you get what I'm doing. Okay, ready to go, you guys? So the first formula is, let's see, what is it? It is, we're going this way. We're going r equals the square root of x squared plus y squared, and the theta is taking your tangent inverse of y divided by x. Okay, so here we go. R equals the square root of x squared plus y squared. We're just going to, and then theta is going to be the tangent inverse of the y divided by x. So take out our calculators. Everything's going to be done using a calculator today. Isn't x 2? Isn't y negative 4? So all I'm going to do, I'll show my work, is I'm going to put 2 squared, which is 4 there, negative 4 squared, which is 16. So take 4 plus 16, which is 20, and take the square root of 20. Take the square root of 20, and that's your r value. The radius is 4 point, let's just go up to, let's just go up to 1 decimal, 4.5. That's the radius of the circle, 4.5. Okay, once again, how did I get that? I took the x and I squared it, I took the y and I squared it, I added them together and I took the square root of it. That's my radius, 4.5. How do I know what this angle is? It's tangent inverse, let's see, tangent inverse of y divided by x. Okay, this is going to get confusing, so I have to show you something. When you do y divided by x, I want you to keep them both positive. Don't worry about the negative part. I'm going to tell you something in a minute, but make this a positive 4 divided by 2. Tangent inverse of 4 divided by 2. I'm in radians, aren't I? Shoot. Let me switch over to degrees. Start again. Tangent inverse of y divided by x. 4 divided by 2. 63 degrees. Okay, everybody got 63 degrees? Again, I'm only using the positive. I'll explain why I only use the positive. That's not my actual angle, is 63 degrees. You need to pretend if you overlaid this, where would 2 negative 4 be located? 2 negative 4. Wouldn't it be down there at 2 negative 4? Where would this one be? 1, 2, 3, 4. Isn't this, well, it's supposed to be 4.5. Is that around 4? I know, it's not perfect. My circles aren't perfect, but would this have a radius of about 4.5 if I overlaid them over each other? This angle definitely not 63.4. You need to add 180 to that so that I'm in that quadrant, right? So that I'm in that, so add 180 to it. And you get 243 degrees. These two should be exactly the same spot, either on an XY or a polar graph. And we understand that they'd be in the exact same spot. I want you to do this now. I want you to do tangent inverse using the -4/2 and see what happens. What happens if it's a -4/2? So you get a -63. That's still not even the answer, right? You need to graph it to know which quadrant you're in. If you always make these positive, the angle that you always get is called the reference angle. It will always be positive and it'll always be less than 90 degrees. And then you can either add 180, subtract 180 right from that in order to figure out which quadrant you're in. So I would just work with positives. Okay, let's do another one. -2, -5. To get the radius, you square that one, you square that one. So it's the square root of 29, which is 5.4. The radius of your circle is 5.4. Okay, now I got to come up with the angle. My angle is going to be tangent inverse of 5 divided by 2. My tangent inverse is 5 divided by 2, which makes 68 degrees. But that's not the answer, because if you overlaid these together on top of each other, which quadrant would this one be in? 3. Was that one in 3? I did this problem wrong. Why don't you guys tell me I did that problem wrong? Go. And I'm recording this. Go. This one is, shoot. Okay, people that are listening, I did it wrong. A +2, a -4 is in this quadrant. It's not 243 degrees. You have to subtract, what was it, 63 degrees? You have to subtract 360 from 63, and it ends up 297 degrees is in that quadrant. 297 degrees. If you overlaid them, it'd be in that quadrant. This one is in the third quadrant, somewhere in the third quadrant. This angle, when I worked it out, was 68 degrees, correct? You add 180 to 68 degrees, which is 248. 248. Final answer. You need to have a visual of which quadrant you're in so that you get your angle right on the test. So just visualize it. You do not have to draw a picture. You just have to make sure your angle is right, and don't do what the teacher just did and do it wrong, because my visual was wrong, and I wish you guys would have said something. Kind of preoccupied today. Not to do it, yeah. What happened was my programs that I had somebody do yesterday, 400 copies, were done wrong. And I just realized, did I do something wrong again?
I pointed it out.
Oh, you did. You need to scream to the hilltop that I'm wrong, Miss Schultz, you're wrong. Just let me know. So, okay, this one is a unique one, and I purposely put this one on here. This one's a unique one, and I'm going to probably put one like this on the test. Why is this one unique? Okay, it's 0, 4. When you do this, what's 0 squared? 0. What's 4 squared? 16. What's the square root of 16? 4. Well, that's easy for the radius, correct? Why is this one unique? When you do the tangent inverse, a 4 divided by 0, what is it going to say on your calculator when you divide anything by 0? You can't. And you can't just put domain error right there. So you just have a visual. where would 0, 4 be located on your old chart back in Algebra 1? 0, 4 would be located right here, right? If you made a bullseye out to 4 circles, how many degrees would that be? Because your calculator's not giving you the answer, but you know how many degrees that is. 90. Where doesn't it work on your calculator? At 90 and at 270 is where it would be undefined, and you just need to know where it would be placed, correct? Any questions on the first part of the assignment? Anybody want more because I just screwed up the first problem? Everybody understand it? Okay, the opposite, I think, is even easier than the first one. They give it to you in polar. This is r and this is theta, and they want you to put it back into x's and y's. Well, this is a no-brainer. You have the formula for the test, correct, you guys? What are you going to do? Just plug it into your calculator? So everybody take your calculator out. The r is 3, and the angle is 270. Can't you just plug this into your calculator to get the x value? So go 3 cosine of 270, 0. Everybody agree with this 0? And then do 3 sine of 270, and you get negative 3. Do you believe me that these two would be identical on the chart if you overlaid them on a chart? Is this easy? Yeah. The first one's harder than the second part. I don't know why I have 80 million of these, but I have 80 million of these. X equals negative 2 cosine of something, and y equals a negative 2 sine of something. If you don't want to work in radians, use the shortcut. It's in pi over 630. How many 30s? Negative 5. Negative 5 times 30 is a negative 150. So you're working with a negative 150 degrees. All you're going to do is plug it into your calculator, and you're pretty much done with the second part. So I'll quickly do it, because we're having so much fun today, now that I've got it under control. Okay, I'm getting for my first x value 1.7. Did you guys get 1.7? 1.7 comma, exactly 1? Okay. I'll take your word for it so we can be done. And just to show you, so I'm not filling you with stuff that you understand, this is x, this is y. If I told you to graph this back in Algebra 1, you'd go a little past the 1 marker and up 1, which would be about right there, right? If I told you to graph this, isn't this 2 circles to the left? And then which way would you have to go, down to do a negative 150, or up to do a negative 150? Up. So you go a left negative 2 and up 150, which would be over here somewhere too. If you put them on top of each other, it makes the exact same answer. Everybody got it? Okay, last problem. They're going to try to trick you again. They're going to try to trick you. And you need to look at the directions. It says we're going from polar to rectangular. And on the test, they're going to try to trick you. This is r, and this is theta. It's not the x, it's not the y, right? So I need to write this as an x and a y. So x equals 4 cosine. This is a radian. This is 2 radians, right? Do you remember what that special 1 radian equals? What does 1 radian equal? 57.3 equals 1 radian. So if this really stands for 2 radians, the angle that we're doing in this problem is 114.6 degrees precisely is what this little angle stands for. 114.6 degrees. And they're going to try to trick you, and they're going to say, change this into polar, or into x's and y's, and you're going to say it is already an x's and y's. No, it's not. 1 radian is equal to 57.3. So You guys figure out the two x's and y's? Anybody have it, or should you want me to do it? I can do it. 4 cosine 114.6. You're getting a negative 1.7. And then, what is it? 3.6. Any questions? Did I go too fast on part 1 or part 2? I can go back to part 1. I'd like to go back to part 1. I feel really bad that 20 million people that are gone that are listening to this video. Everybody should be able to find the R very quickly, right? And I want to just make sure you understand how to find the tangent inverse. When you're doing the tangent inverse, keep these both positive. You're going to find the reference angle. Hey, just a reminder, if you're working with this first quadrant, people that are listening on the video, it is the angle, right? If you're in this quadrant, don't you have to subtract 180 from that reference angle? If you're in this quadrant, you have to add 180 to that angle that you're given. And if you're in this quadrant, you subtract 360 to get to the angle. You never work with the y-axis. Did you see how I added 180, subtracted 180? I worked only on the x-axis values. Got that, you guys? Okay, last part. I don't even know what the last part is. Change into an equation form. Change into an equation form. So, really easy. R equals a negative 3. Everybody see that? All you're going to do is look on your formula sheet, and there are 4 of them that we did. We did x equals, y equals, r equals, theta equals. Everybody see the 4 that we did? You're going to change, obviously, the letter to what r stands for. What does r stand for? X, the square root of x squared plus y squared equals a negative 3. Everybody see what I did? I changed the r to that. Now I'm going to square both sides, and you're going to see something which is really cool. I appreciate it. You guys probably won't. This and this. You're not going to appreciate this, but maybe you're going to go, aha, I get what she's doing. So, in 9.1, did we learn how to graph all of r equals a negative 3? Do you guys remember what it makes if you're only given an r? That means theta can be anything it wants to be, right? Doesn't it make a circle at a negative 3? Do you guys remember doing this on 9.1? Right here, it makes a circle. Whoa, sorry, but good enough. That's the polar form of a circle, okay? Back in college algebra, this should ring a bell from college algebra. X squared plus y squared equals 9. This is also an equation of a circle, right? Radius is the square root of that, which is 3. Does that look like a radius of 3? And it's at the origin. So they're just proving to you that you learned the algebra version of it and you learned the polar form of it, correct? Kind of cool that you learn both ways. Interesting, Matt just came home from college, picked him up yesterday. He had calculus with polar equations. He said, I don't know. He had these cardioids and limacins on the calculus test yesterday, and it was 30% of the grade, and it really wasn't the best. And I'm thinking, we just taught cardioids and limacins, the other day, and he's doing it at the calculus level, way more in depth than what you guys did. So, okay, x equals 2. What does this make? Look on your formula sheet. What does x equal on your formula sheet? R cosine of theta equals 2. Okay, now they want you to go back to the wonderful chapter 7. Do you remember chapter 7, the dreaded chapter 7? In order to get r alone, can I divide both sides by cosine of theta? See what I did? This is a very easy chapter 7 problem. And then the back of the book is going to say, isn't 1 over cosine the same thing as secant? Aren't they reciprocals of each other? So the back of the book is going to write 2 secant of theta. I will accept this, I will accept this, but the back of the book will change it and reduce it. Final answer. Any questions on the last part? What you're supposed to understand is these this was going a point to a point, a point to a point, a point to a point. This last, and then this same thing, a point to a point, a point to a point. But this last part went from an equation to an equation, which made not a point, but an actual shape. Correct, you guys? Okay, what's the assignment? Page. How many of each do you need to make sure you understand this all? Let's see. 1, 2. Let's see. I had them do them all. I'm not going to have you do them all. I'll just have you do the odds. I'll have you do 15 through 27 odds. You have 3, 6, 7 problems to do. Is that a lot? 15 through 27 odds. No, you have more than that. As I said, that doesn't even add up. 9 problems. Page 572. Sorry, 7.